Good afternoon and welcome to the Power of Data, Harnessing Ethanol Plant Information for Increased Profitability, a webinar sponsored by Direct Automation and presented to you from Ethanol Producer Magazine. I'm Holly Jessen, the managing editor of the magazine, and I'd like to welcome you to our webinar. And now we'll have a word from our sponsor.
Thank you for logging into this special free webinar hosted by ethanolproducer.com. My name is Carson, and I'm proud to work for the sponsor of this webinar, Direct Automation. Direct Automation values your time and respects your decisions. We use our expertise in automation and IT to make sure your DCS, PLCs, lab, accounting data, marketing data, CMMS, and IT are working together to give you the results you desire. We work hard to make your plant perform the way you want it to. Direct Automation does all things that involve automation, networks, and data. Our strength is in how we synergize your plant. Our DCS migration services will get you a DCS that takes advantage of our automation features that can ease your workload and stress and even provide you with a payback. We understand that the DCS is the interface to your plant, and this is an intimate bond that has to work. That's why we take a preventative maintenance approach and offer 24/7 support. That is mission critical, but we don't stop there. We will get you APC, plant wireless, acoustic monitoring, virtual operator logs, descriptive interlocks, wireless machine health, and pie in the sky. In addition to our DCS and automation services, clients have also found our IT services to provide ease of mind. If you are tired of working with companies that are used to average office IT needs and need someone that understands your needs, call us. We will fix you up. Direct Automation provides secure and seamless IT support that will keep you from having to worry about downtime and aging hardware. But whether we service your DCS or not, you can take advantage of our pie in the sky services, which is the topic of Paul Zweifel's discussion today. Let us get your data working for you. Call 605-428-4300 to set up an appointment today. That number again is 605-428-4300.
Thank you. Now we'll go to our first speaker. Scott Wise is a JUMP Technical Enablement Specialist with SAS.
So hello everybody, my name is Scott Wise and I'm a technical engineering manager here at JMP, and we're a division of SAS. Some of you might have heard of SAS before. SAS is the largest private analytics software company in the world. And JUMP was created over 25 years ago by SAS co-founder John Saul to provide analysts and engineers and researchers and really anyone dealing with data an opportunity to interact with their data on their own without being a programmer, without being a statistician. And so it's very, very valuable, and it's something that a lot of ethanol producers, among other manufacturers, have been going to actually help provide the analytic breakthroughs in their data. So let me start just real briefly on what is JUMP. I was an engineer in many different industries. I used to do a lot of things in spreadsheets. I struggled as the amount of data started to rise. I struggled to do things the old way, which is pretty much through tables and very static graphs. And I got introduced to JUMP, and it really was eye-opening, and it became my everyday tool. And big part is it's a very dynamic package. Now, I'm not going to be able to demonstrate JUMP to you today because we have a PowerPoint format and a limited amount of time. But I'm going to describe things where you really can interact in creating and drilling down on your data seamlessly, fast, very quickly, not only to do that, but also to have the right tool set, a very powerful tool set in your command so you can get the right tool at the right time It's very visual, doesn't mean anything. If I tell you we have a really high probability that something's different than another, and I go try to talk about p-values to my manager, you want a good graph. And last, it's flexible. So if we do this type of analysis weekly, daily, we can definitely automate and customize our work. So the whole idea here is JUMP speeds up your time to discovery, from getting the data in to analyzing, exploring, like we like to call it, modeling experiment where I can ask some questions, and finally report out the results. So what I'd really like to do is make this as educational as possible. I'm going to pick 3 common areas where ethanol producers often are needing to make better decisions and get better visibility. There's a lot of data out there, but again, you got to figure out what to do with it and help it answer the right questions. So these 3 areas are improving quality, increasing yield, and getting better experimentation on my research side. So I'm going to start off with the first one. I have a large bioenergy, biotech company here. We are trying to have decent quality, but we are seeing in our assays, we are seeing that we're having contamination over 50,000 parts per million. And so the data gets brought into JUMP. JUMP is client desktop analytics software. JUMP will enable you to be able to really drill down on your data very quickly. I can bring it in from databases. I can bring it in from a text file. I can bring it in from Excel, which we integrate with. Basically, if you have a driver for your database or you are using any commercial software, we can bring it in. And once it's in here, then I can start asking the questions. Where is the high contamination? When does it start? What's contributing to it? And as you can see in this graph here, I'm starting to get more information. And if I was showing you this live in JUMP, this would be a blank square that I would start to throw in the columns that I want to see. And therefore, on the left-hand side, I brought in my batch assay part per million. On my bottom axis there, I have my date. And you can see over time, I'm starting to see more high points, now colored red for me, over 50,000 parts per million, starting about, let's say, January of 2010 and forward. I can continue, and I can bring in any other column, any other parameter I have. Is this being driven by shift? Can I break this chart in 2 ways by shift? Can I look at it since days since cleaning? Can I look at it in terms of suppliers and reactor vessels? And the whole idea is to do these questions to drill down on what's really causing it. In this case, it turned out to be a specific supply and reactor combination. Now, I've got this discovery where I want to now quickly visualize what's going on. So this last chart here, this is actually an interactive bubble plot. And even though I'm only in PowerPoint, I can actually save a lot of my visualizations as Flash, as also as HTML5. But here's one that I have all my reactors. Those are the bubbles here. The size of the bubbles is the amount of batches I had in each reactor. I can see it change over time, such as reactor 2 here. I might switch to reactor 1. See, I click on it. I can even label. I can just hover over it, and I can understand all my background information on it. And so as I click through here, I can see where reactor 1 got very high. I also asked that this thing be split by supplier. So I can see it's mainly supplier A and supplier C. That's generating my bad quality. So I can split, I can combine. And the cool thing about this, I'll just leave on a couple of reactors. Cool thing about this is I can even automate this thing over time. And I'm going to hold my shift key down. I'm going to highlight them both. And now you can really physically see it pop out. And I've seen great management decisions made by being able to really interact with a chart like this instead of getting just a boring static line chart. So this is an example of an interactive bubble plot. Okay, so we have another situation here. And on this situation, we've got an ethanol producer, and we want to increase our yield. So hopefully this feels pretty familiar. Now, I can, again, go into this interactive graph building, and I can just explore my data visually here. I can actually see that there's an increase. Didn't matter the fermentation vessel, there seems to be an increasing trend going on by date and by batch. That's awful interesting. So again, I want to ask some questions. What components are driving this? Do I have other information that can actually help me figure out what's contributing to high amounts of ethanol yield? And can I come up with a way to model this? In other words, to create a working model where I can do what-if questions. And so here's a distribution, and it's just a set of distributions. You can see I've shaded the high ethanol yield bars, and you can see it flows into all the other graphs, and it's showing me trends, such as the little bimodal situation with DP3+, such as kind of the low settings here for acetic acid. And I can further put a right model on this to actually answer my question here. So in this case, I use a tree method. This is a bootstrap forest. It ran a whole bunch of decision trees on seeing how, just statistically, how important these terms are, these factors are to actually driving high ethanol yield. And you can see by the big bar, those are the ones that are most important. So it's really easy for me to see that DP3+, maltose, acetic acid, glucose were the biggest ones. And they can help me explain X% of my model. So what this will look like, here is another interactive flash that I've saved into the PowerPoint. Here's that ethanol yield. Notice as I click around, you see it highlighted in the others. This is a great thing about JUMP. Your inside JUMP is interactive. You show results outside of JUMP, you can still maintain a lot of interactivity. And this makes better decisions. Now when someone says that's great, but just highlight the low acetic acid and let's see what happens. Now when I highlight those, I can see it highlight back into the others. So this is just, we call this dynamic linkage. And oh, by the way, if I was in JUMP, as I'm highlighting these bars, it's highlighting those representative rows in my data. So if I wanted to subset my data, I could immediately go and subset it. All right, and let me go on to the last case we have. So this gets into experimentation. So the first two we looked at are kind of situations where I'm looking in the rearview mirror. I collected past data on quality, past data on ethanol fermentation yield. Now, I want to really not just fix bad situation in the past, but I want to learn from that and actually create an optimal situation. I want to come up with the right settings that's going to give me perhaps the highest yield, the best quality, maybe at the lowest cost. So here I have some competing goals I have to deal with. And what we have available within all the methods within JUMP, all the descriptive, comparative, predictive methods, is the ability to do design experiments. Design experiments are ways of being able to take a lot of factors, change up those combinations in as few experimental runs as possible. The alternative is to do like one factor at a time changes, which takes forever. You try to hold one constant, change one thing and hold everything else constant. So you can see here on this design, I have 16 runs, and where you see a positive one, that's a high setting. Where you see a negative one, that's a low setting. You can put the real settings in, but I protected this for our customer here so we could share this data. So my question is, can I create an experiment that's going to give me, again, the optimal settings with the minimum amount of runs? And so we were able to go and generate an experiment where they ran out and took the results for each of those runs. We were able to go out and do a model. This was based off a regression model, kind of a fit line model, after I ran the DOE. And now I can see what was the most important. And I can see that base was the most important factor. And I can see that's lean in time interaction. That's why you see there kind of a multiplication symbol up in there. That one is the next, so on and so forth. And where I can finish is not just back in other graphs, but I can actually do a profiler. This is a prediction profiler. This is a graphical representation of my model. And this is another thing that I can actually make interactive. So you can see here, as I start to move on up base and I start to decrease my to lean, you can see how that is changing my yield, how that is changing my assay, how that is changing my overall cost. And this is interactive. Inside the jump version of the profilers, I can simulate by random, basically changing up my settings in some random pattern, or I can do a distribution of them. I can as well pose a lot of what-if questions. Again, I have cost as an output, but I could apply cost in here at each stage and optimize in terms of cost. I can ask jump as well to optimize between these three outputs, but even with different weights. So it's a very, very powerful tool, and the ability even to take this outside of jump is just wonderful. So this made a big difference when I thought I had the right solution, and I would take that into the production meeting or the engineering review meeting, and I'd say, these are the right settings, and someone would say, wait, we can't put that much base in. You're going to have to take the base down. What will happen? Now I can just change it and show them what's going to happen. I don't have to go back and do something static and copy it into a PowerPoint or do it in Excel and show a sea of numbers. Now we can just do it interactively, so it's almost the ultimate what-if tool. Okay. So just to wrap up what you've seen, because I'm about up on my time here, jump is going to speed up your time to discovery. It is the best all-around tool. If you're doing too much in spreadsheets, if you might have other static software that you're doing analytics with for statistics, if you have separate visualization packages, you can replace them all with jump. Everything comes together. And where you can learn more, we have not only free 30-day trials of jump on our website at justjump.com trial. Definitely take a look at us in social media. See what the customers are saying about us, because we definitely make a huge difference in the lives of engineers, analysts, and researchers, production managers, really anybody dealing with this type of data, to actually speed them up so they're not wasting time and they get better answers and they can show it better. And so please take a look at us. I particularly like our YouTube videos and also the customer success stories. We thank Holly Jensen for her for highlighting one of our customers in the Ethanol Producers Magazine, Put a Data to Work. That was out in December. Also, on the JUMP website, we have a lot of customer stories, such from Novozymes and Bloom Energy, and even other related biotech, biohealth, and chemical companies. And please check out and see what they're doing with their data. So with that, I will wrap up, and I'm open for any Q&A as well.
Thanks, Scott. We will definitely be having a Q&A. We'll hold that till the end of the session, but attendees can ask questions at any time throughout the webinar through the webinar platform. Now we'll be going back to direct automation.
Direct automation wants to make your DCS work harder for you. Nearly 40% of the ethanol plants today operate with a legacy DCS system that they have to replace in the next 5 years. If this includes you, call Direct Automation for a free proposal and DCS evaluation before the pressure to replace yours starts to ramp up. We will travel to your location, inspect your system, present you with ideas for improvements, and provide you with an in-depth proposal to improve or replace your aging system. Find out why plants are switching and get a DCS with a payback.
All right, now we'll go to our second speaker, Shane Seif. He's the Principal Software Engineer with Trident Intech LLC.
Thank you. Good afternoon. My name is Shane Seif, and I'm a Principal Partner at Trident Intech LLC. Today I will be presenting a high-level overview of our Trident Workbench solution. Our goal is to show you how you can better manage and analyze your data to make your plant more profitable. Trident Intech was formed back in 2009 when we split off from our DCS brethren to specialize in data collection and analysis for manufacturing companies. Our objective is to make your plant run more efficiently and help you better leverage assets you already own today. The solution I'm going to show you today is installed at 51 ethanol plants today in production, and this, it supports a broad range of DCS platforms and plant designs. The Trident Workbench is a web-based suite of tools installed at your plant that you own. There are no monthly premiums, and the solution is compatible with a wide range of browsers and devices. So when you're wanting to access or review some of that data, you can be looking at it in the control room, in your office, the front office, a corporate office. You could be logged in from home looking at it, or even looking on your cell phone when you're sitting out on the golf course enjoying some sun, if we can ever have some good warm weather. Here's a set of some of the devices that we've tested it on. How does this solution fit into your plant? In general, most ethanol plants have a process network and a business network. On your process network, you have all your client machines, and there's typically a historical device that's tracking all of the details that are going on within your DCS. In addition, a lot of the sites will have an independent lab where your HPLC, your GCs, and your NIRs are all sitting out there. It may be on your business network, it may not. And what we do is we drop in a server in the middle of that, which allows us to pull data from all those systems in real time and share that data real time across all those different mediums. So what we'll do is we'll start out talking about the data collection piece of the solution. The primary interface for collecting that data provides you the ability to build a life cycle around all the data that you collect today. But it's somewhat of a misnomer in the sense that the lab not only collects data for your lab, but it can collect things like downtime and production reporting and send out email alerts. So a lot of plants have actually used it for a broader range of functionality as opposed to just the lab itself. Some of the key benefits, it's a configurable system. So when we go to your plant, we can install and configure it to match how you're collecting your data today. But then we can put a quality controlled data lifecycle around that. It provides real-time data feedback, so any data that's put into the system is immediately available at any point where you can look at it. It ties directly into your devices, HPLC, GC, NIR devices, which allows you to pull in that data accurately, save some time, and improves the quality of the data that you're collecting. In addition, lab managers and production managers can create what's called gold standards and profiles for all the data that's being collected. So you can flag an individual data point that might be outside of a range that you're looking for. You can alert the user right away as they're entering that data, and they can react to that immediately. It can, as I mentioned before, it can also do like alerts. So a lot of times if you have downtime or transfers or certifications, it can email those, send them to third-party systems. So we'll jump into the system quickly, kind of going through some of the core features. We won't necessarily be able to go through everything, but we'll try to cover as many of them as possible. Again, it's web-based, so you can access this anywhere using any kind of device. Across the top, you'll see a navigation which can be customized based off how you want to collect the data. So as I said before, because you can actually collect data for areas outside of just the lab, it's very beneficial, and you may want to organize it differently. Users can interact with the data, so they can change the trends and look at different aspects of, in this case, their fermentation. And you also notice that on these graphs there is a gold, what we refer to as the gold curve associated to these graphs. This is the standard that you can establish, your target, the goal that you're trying to achieve, so that you can continually compare your data against that curve. Along the left-hand side, you'll see a list of your fermenters. Because this is real-time connected, you can see your current levels and temps for each of those, and it will also report what the current reading, when the next scheduled reading is to occur. If a user were to click on one of those fermenters, they would be provided immediately a report, and in this case we're showing a batch report summarizing how that fermenter is currently operating. Again, you'll see all of this data is compared against that golden curve. Because we have a profile associated to this, it will flag items that are outside of spec. And not only does it have the fermentation HPLC data, but it includes other data that may have been aggregated from your DCS as the process goes along in firm attributes. And the users can also review what kind of ingredients have been added or what the state of those ingredients being added to that batch are. As you step forward within the fermentation form itself, so when the users go in and enter the information that they receive for fermentation, this data is automatically collected, and we'll talk a little bit about the life cycle of the data here, but then we'll also get into some details how that transcends into other forms as well. But you'll see on the left-hand side here, for every task where you're collecting data, there is this quality checkpoint. Basically what happens is as the user enters their data, it will flag according to things that are outside of spec, and if by chance, once they've reviewed that data, they can then quality check it, and then it makes it read-only and moves it over to a read-only state, and it is confirmation that someone's actually looked at it and reacted to that data. You can see that we can pull HPLC data directly into the system, and it will flag even as you're typing the data whether things are outside of spec, and if you move a mouse over that field, it will tell you why that data is outside of spec. We can aggregate data from the DCS as well, so we can customize it. I'm showing two separate samples because these two plants happen to collect their data differently. In this case, some of the data can be entered and some of it can directly be pulled from the DCS and aggregated. And in this case, this particular site has an NIR test, so they're testing their corn as well associated to the batch, so they can tell what kind of moisture levels and starch they're working with. We also do continuous fermentation as well. I won't go into this in depth, but I just wanted to touch base and say that we can do continuous fermentation as well. In general, the data collection process within the lab establishes a life cycle for data collection, and it's much more easily identified when you look at like data forms for operations. But it works the same as batch, they're just a longer cycle. In this case, when the user comes in and starts their shift, they can create that form, assign which shifts they're working, put in their core details, save it. It will generate a schedule of readings that they would take throughout the course of their shift. They would enter their data. It will flag accordingly if it's outside of spec. They can quality check the items as they move through their shift, save that, and at the end of the shift, they complete that and close out that form. We can also pull in data from any other data sources, so again, NIRs, GCs, and HPLCs. But once that's completed, then the next user comes in and they start that same life cycle for the data. In this case, we can also support customized forms to align with how you might be doing work today. So I know a lot of plants are using an ethanol or a transfer sheet that is in Excel. And so we can actually mirror that form within the system as well. Users can enter their start and end levels, and it will automatically calculate that data. So now not only it's not sitting out on a shared drive in a bunch of separate Excel files, it's out on a stored database. You can analyze that data, and you can also send out email alerts from it. In addition, I'm showing a downtime form, so we'll take a scenario of our dryers go down. In this case, instead of making a bunch of phone calls, you can go in, fill in some core information, apply some details, save it, send out an email alert. The nice thing there is when you're going back and looking at your trend for your dryers and you say, hey, that appeared to be down, now you have some data to support why that dryer was down. There's a lot of instant reportable reports available within the system. In this case, I'm showing a compare batch. You can look at the scat lines here that show how each batch is performed relative to each other and relative to the golden curve. So you can always identify which is the odd duck out. Go look at the data. And there's a number of other forms where you can pull some statistical data as well. These reports can be exported and put up on bulletin boards or whatever you would like as well. And then last but not least, all the data within the system is exportable into Excel, which allows you to export it out to a software solution like Jump or Sigma Excel. In this case, you can turn around and you may be entering data into a spreadsheet that looks like this today, but the system can automatically generate that spreadsheet for you now. It can also generate outputs so that you can import them in some of the analysis tools, which makes it easier for you to do that analysis. So now that we've talked about the input side, the manual input side, we have a piece called the KPI module. In this piece, the goal of this system is to provide a number of significant reports from which you can run your plant and get automated results. It can attach to multiple different systems. So instead of you spending all your time trying to aggregate all that data and pulling spreadsheets together, you can now have this system automatically go out and collect those key pieces of information that you want to work with. Key benefits is you're not spending your time doing all that additional data assembly. You'll get the data consistently, so say someone leaves the plant and someone else comes in new, you're going to get that data consistently regardless of who's there because that's what the system does for you. It integrates with multiple different DCSs. It can pull data from your lab system, corn receipts, shipments, or any other data source that you want to feed and report on within the system. It gives your users really the ability to focus on the micro details as opposed to the macro details because this does all the heavy lifting for you. And you can actually set up the KPIs to track the data how you want to track the data, not how the system wants to track the data for you. For the KPI screen, again, we have an overview screen. It has some graphs and gauges here. It's not as robust as our dashboard solution, but it does still demonstrate what, some of those key things you might be looking at, and that data is interactive, so you can go back and forth and look at details associated to those key attributes. But the heart and soul of the KPI system is really the KPI definitions themselves. So instead of us tracking every single bit of information that's going on in the DCS, most sites typically look at between 150 and 400 points of data, and they might be looking at averages, they might be evaluating how much certain things were on in an hour or whatever the case is, and our system allows you as an end user to go in, add a KPI, you can link it and assign it to different groups, decide if it's going to be a 30-minute interval, 5-minute interval, 1 hour, or daily results, whether you're getting the current readings or averages, and it can aggregate that data. In addition, you can create high-level KPIs that take multiple factors into account and create calculations. So evap to beer feed is a common one that a lot of people like to create because if that is a flat graph, then they know their plant is running smoothly. As output from that system, the KPI will generate about 20 reports on a daily basis for you automatically. And in this case, I'm showing 2 sample daily reports. In this case, you got the daily production report, which can be automatically emailed to you every day and is structured how you want to see the data, not necessarily how we tell you you should see the data. In addition, it's an ad hoc report, so you can go back and run that report at any time. And the other example I'm showing here is kind of a scrubber report, so now you can see what happened every hour across the whole day, and so then it helps with your environmental reporting as well. Then there's a whole pool of reports that are monthly based, so we can span from the front end to the back end of your process, and we can segment those into different monthly reports that will collect core data that you want to work against, metrics that you're looking at to help more efficiently run your plant and make sure things are going smoothly. And it can generate that, and again, those are ad hoc reports, and all that data is exportable as well. Over and above that, if you've defined KPIs that aren't necessarily in one of the reports, you still can do that, and we have some analysis tools in there. Obviously, we're not going to do as robust analysis as JUMP does, but in this case, you can see the user can pick a KPI, they can add it to their system, and we can add standard deviation, average mean. You can now look and you can see your outlier data points. This is especially helpful if you run like an enzyme test or some new vendor trials, and you can kind of look at that data and it gives you instant ability to review how that process is performed. Having said that, the last portion of our solution is really the visualization, making it easily accessible, and we have the Trident Workbench that pulls all of this together and makes it all visual. The unique thing about our dashboard solution is that not only does it present a lot of information, but you can configure that dashboard and put the information you want on the system. It's real time, and again, it's web-based and does not require you to add any additional software to your viewing machine. So whether you're viewing from home, it's not going to affect your home PC, but you can watch what's going on at the plant while you're watching the Super Bowl. Key benefits, it's a unified user experience. It shares that data with everyone immediately. It's configurable by the end user, and you can make as many of these as you want. As I said before, it's web-based, so you can view it anywhere in the plant or outside of the plant. It has a variety of controls, and we can link to your DCS, your lab, KPI. And the nice thing is because it's a simple web-based solution without any extra packages, you could go out and buy an LED TV at a Google TV device and pop this up anywhere in your plant for like $600. A variety of user controls. So here's just a sampling of some of the different user controls. In this case, you can see one of my favorite is this radar control. It allows you to look at a vast variety of different portions of your system. And these values will slide real time as you're observing in and out of range. When they're outside of range, you can tell that that is outside of spec. And so now you can go and take a look at that. But there's different trends. You can see your fermentation profiles. And these are dashboards that you can build yourself. You can build as many of them as you want. As a matter of fact, I have some users who build dashboards just for their cell phones and some who build them just for the big screen. And it's really in your control. And it's as simple as just selecting the different controls you want, drop them on the dashboard, assign the attributes, link them, and you're good to go. So with that, I would like to say thank you for allowing me to present our Trident Workbench solution. That solution, again, has a data input piece to create a life cycle around your data. It has a portion to aggregate and report on your data, and then to visualize your data. We can do a more detailed walkthrough at any point in time. Feel free to give us a call at 651-447-5558, or go ahead and email us, and we'll try to set that up for you. Thank you.
If you are attending this webinar, it means you understand your data has value. You know that when your data is put to use, it will help you make clear and confident decisions, and that will make your job easier. Direct Automation knows your time is valuable, and we thank you for spending that time to consider Direct Automation and the Pie in the Sky product to support the important decisions in your plant. We also thank Ethanol Producer Magazine for recognizing Direct Automation as a viable source for the data and control needs. And thank you to all of the prestigious panel members for your contributions and expertise.
All right, thank you. Quick thank you to Shane for his presentation. And now we will move on to our third speaker, Paul Zweifel. He is the president of Direct Automation, the company that is sponsoring this event.
Good afternoon, and thanks Ethanol Producer Magazine and BBI for hosting this webinar. We are excited to let people know about our Pie in the Sky. My name is Paul Zweifel with Direct Automation. I have 18 years of experience in automation and IT. We created Pie in the Sky to help plants manage and report their data more efficiently and with less cost. Why does Direct Automation fit your needs? We are growing in double digits each year, providing services and solutions to industrial facilities across the nation. We develop DCS, IT, and database systems for our customers that are easy to use and provide the tools to run your plant simply. We know data drives capital projects and operational decisions, so Direct Automation pulls all the data together with Pie in the Sky. Your time is valuable, and we provide a tool that reduces your efforts in presenting your data in the form you request. The problem at hand, excuse me, your data is scattered about in databases in paper form with no single collection point. This creates the time-consuming task of requesting data from multiple sources and even multiple people. The cumbersome process is unsynchronized and is likely to have many errors in the reporting. With problems like this, you dread the task of compiling data to present to your management. You've all been there, flipping through notebooks, scrolling through spreadsheets, logging onto DCS historians, talking to the maintenance department, requesting data from commodities and accounting staff, all to put together one report about a project. What if? What if you can get all your data in one integrated location from any internet-enabled device? Quickly trend and create custom reports with minimal effort for any level of your staff at your plant. What could you learn? Data in your control room, boardroom, at your home computer, grandma's house, and your mobile devices. Get your data quickly and learn with ease. Introducing Pie in the Sky, the most user-friendly, comprehensive, and secure data integration solution on the market. Data from anywhere, automatically. Any source, both internal and external, also with tools to convert paper to searchable, meaningful data for your team's use with other data sources. Back to the problem at hand. Pie in the Sky can bring all the data together to eliminate that cumbersome task of gathering your data around the facility. You can now create interactive reports with ease. See what you can do with your data. Compare plant output to market prices, real-time estimated margin calculations, and more. Build interactive charts pulling lab, process, and market data with calculations previously only available with the painstaking task of using tools such as Excel. Alert your team with the setup of text or email alerts on deviations from any connected data source as soon as a threshold is exceeded. Secure Windows user integration, single sign-on to access all your data sources. Time to review some of the features that Pie in the Sky offers. Pie in the Sky is a data hub or portal for all your data sources with cutting-edge reporting features. Extra features like forum discussion boards for internal and external use are also available. Classifieds for excess parts inventory or sharing spare parts inventory with others, as well as document management for SOPs, drawings, safety forms or information, and more. Calendars to help communicate work schedules or other plant downtime scheduling. Benchmarking is an option that plants can participate in or not. Your data is always secure, and you choose what is available for benchmarking. Another feature is Pie in the Sky provides lab standards to make sure when you're comparing your lab data with others, you are using the same lab standard. Safe and secure data, synchronized and available indefinitely from any internet-capable device. With Pie in the Sky, you can define your reports, charts, and graphs, and we offer many options, and you can choose. We combine, host, manage your Pie in the Sky environment, taking the burden and risk away. Your data is preserved on your site, so you never have to worry, and Pie in the Sky is SOX compliant. Your data is real-time, fast, and reliable for all your needs. We monitor 24/7 to provide you the level of support you can expect with a world-class software. We can even access the historical data you have today to get you up and going with Pie in the Sky right away. Pie in the Sky has custom security that lets you define each user's environment and allows for a secure external view of selected data for your vendors if you so choose. The reporting section of Pie in the Sky contains client-driven solutions that allows you to create your own views or, with your direction, have us take care of it for you, and that's included. With alerts, you can be notified immediately of goals that have been reached or issues as they may have arisen, which reduces the time required for you to monitor your data. Pie in the Sky has features such as geographical mapping and overlays with interactive filtering that takes you beyond the rigid reports, which only provide you a single view. Here are a few examples of reporting options. Radar charts of process variables or lab data if you would like. Corn data, moisture, test weight, daily receiving quantities, etc. Traditional trend lines, scale tickets on corn, DDGs, and more. Mapping your area of sales or grain procurement. Rich possibilities of Pie in the Sky reporting. Optimize enzyme dosing to save you money and reach peak performance. Don't just take the vendor's recommendations on dosing. See it for yourself using your own data. Also, find rockstar operators in your facility that can help you improve overall plant efficiency by training other operators. We have lots of options, and you get to choose. With Pie in the Sky, you can now overlay operator logs on the reports, making it easier to understand a data anomaly both today and when reviewing your data in the future. The advantage is, next month, when you're looking at your data, you can see the comments from operators during that time frame you're pulling your data, like sweeping grain bins or changing a basket strainer. We also bring a whole new context to reporting by adding color overlay, helping you understand the effects of, say, pH on fermentation performance or chemical dosing on corn oil production with other process or lab data. The possibilities are endless. Pie in the Sky adds your CMMS system to the portal. So you can see work order statistics like average hours spent on work orders, see when your maintenance department is most efficient, or put work order data with plant data to prove how a new impeller on a pump helped flow through the slurry system. With Pie in the Sky, you can begin implementing predictive and preventative maintenance with the link between your CMMS system and your DCS. You can now even understand what's causing the most downtime, so you can focus on that problem. With Pie in the Sky, your procurement statistics are also available, so you know where you spend your hard-earned money on maintenance, and if that same maintenance is causing you downtime. Benchmarking your spending with others, and, of course, only if you choose. Bringing your DCS daily summaries to the forefront to simplify access to this valuable information without connecting to the DCS, and have it any time. Pie in the Sky allows electronic operator logs to create a filterable and searchable log by area. If you're having an issue with fermentation, you can filter your logs to hone in on the potential issue outside of your lab or DCS data and resolve it quickly. The logs are historized for future troubleshooting of your process as well. Pie in the Sky is on dedicated servers in a secure, managed, disaster-proof regional data center near our office in Sioux Falls, South Dakota. Integration between Pie in the Sky and the client's network enables secure, single sign-on access, and when off-site, access is convenient and via a secure web portal. Security is number one, and authorization is made on a per-user basis, no public access, and no unauthorized data sharing. And this is all dictated by our clients. Any data source can now be available. Adding external data to your own data provides a whole new level to your reporting. Include weather data when comparing plant parameters, or see past, present, and forecast weather to understand how it affected or may affect things like grain procurement, as an example. You can now know the rainfall and heat units of a procurement area, or once grain is delivered, see how weather affected things like alpha toxins to make better procurement decisions in the future. How about predicting cooling tower load with forecast weather so you can adjust your plant before there is a problem or decide to run your chiller or not to save money? Trend your competition's cash and future grain prices. With this, you can now see how they react to changing market conditions or target an area where grain is the most affordable. We can even tell you how far you can truck grain affordably. Any web data or public data can be implemented into the system automatically and reported with other data sources. Pie in the Sky is a non-proprietary, proven, stable, very customizable, and effective world-class data solution for our customers. Direct Automation knows how important your data is to you, and that's why we, with the input of our clients, developed this software over the last 2 years, and we are proud to offer it. The implementation. We work closely with your teams to ensure top-performing Pie in the Sky implementation that meets your needs. We address your concerns and develop an implementation plan to suit. Ongoing maintenance and upgrades are included with your subscription to Pie in the Sky. Optional television displays are also available, and if you need us to help implement a plant Wi-Fi network to help maximize your Pie in the Sky business network or DCS experience, we can. Every client has different needs, so please contact us so we can understand what you need and get you a proposal. We know you will find Pie in the Sky valuable. That is a time savings tool and keeps you informed to allow you to make the best decisions possible. In conclusion, data needs of a business are becoming more complex. Big data is the word of the day, and solutions to handle the volume, frequency, and variety of data sources are becoming more prevalent and mature. Direct Automation works closely with process automation systems which can generate large volumes of data, so we understand the challenges of integrating this data with other systems. We recognize that this data is important in making decisions related to capital projects and ongoing business operations. An advanced solution is needed to bring together the multiple data sources within your business to allow people with different roles in the company to have access to the information they need to make the best informed decisions possible. We know you won't be disappointed. Thank you for your time, as we know it is valuable. If you have questions about pie in the sky or would like to schedule a demo, please contact us at 605-428-4300. Thank you again.
Thank you, Paul. Just a quick reminder that if you have any questions, you can, all attendees can send in questions while the speakers are talking. Now we'll hear from our last presenter, Sabrina Trupia. She is the Research Director for Biological Research at the National Corn to Ethanol Research Center. And we will take questions as soon as Sabrina is done speaking. Sabrina?
Thank you. I just wanted to thank Ethanol Producer Magazine and BBI International for giving me the opportunity to present some information. It's a little bit different than the 3 presentations that you've been hearing up until now, but it's kind of fundamental, and it might jog your memory as to why you should at least consider their systems. What I'm going to talk about today real quickly is giving you a bit of a broad definition of quality assurance and quality control, and then I'm going to follow up by showing some examples of the type of work that we've done in the labs in the pilot plant at the National Corn to Ethanol Research Center, and then I'll discuss it a little bit and take your questions at the end like everyone else. So let's get started. We have a facility that has been around since 2003, and we've done a number of distinct pilot plant runs for different clients and several lab projects. And just as a reminder, because we're not an ethanol plant, we don't continuously run, and the longest run we've done, it was a little bit over 2 months. And everything is sized 1/200th of the size of a 50 million gallon ethanol plant. In a pilot plant, we have a laboratory that can handle smaller scale fermentations as well. So what is QA/QC? And as I was looking for some illustrations to describe this, I came across this yin-yang of quality assurance and quality control. And I don't know if you can see it, but it says in the quality assurance part, it says prevention, and in the quality control part, it says detection. So if you can think about the medical field, prevention, detection of illnesses, it's pretty much the same thing with any quality assurance and quality control in any industry. The prevention would be making sure that everybody follows industry standards, and detection, the quality control, is that if something is off spec, we'll find out. So how do we do that? Well, we perform a lot of tests, which is why we need things to handle all the data that get produced and to see if the samples are within specifications. Typically, we have a QA plan at NSERC. We know what we're testing and how many times we test something. And then we also have a QC, a quality control program. What does this mean to an ethanol plant? What does it mean? I mean, for a production facility that produces, I don't know, gadgets, that's clear. For an ethanol plant, what does it mean? Having good QA/QC means that you can solve any problems that could come along the line. So risk management, what are we testing? We're testing contaminants like in the feedstock and contaminants in the co-products. We test the ethanol quality, and we do front-end and back-end tests, and we solve the problems such as stuck fermentations, or at least we try to prevent those. We do mass balance to know how much stuff goes in and how much stuff comes out to see if we can improve our yields, and we recognize trends leading to any mass balance problems like poor yield performance and so on. And but then in the middle of this, of what comes out after what goes in, is fermentation management. And this is something that doesn't have any official guidelines, but it's really important because in order to maximize ethanol production and minimize stuck fermentation and other fermentation problems, we need to be good at QA/QC practices in the fermentation management. So taking samples, analyzing, seeing what's in there, and catching anything ahead of time. So in the lab, we do quality control in 3 different ways. We do method validation, so any assays that we have to run, we need to validate them in the lab. What tests we decide to use, what is industry standard, how well do they work, those kinds of questions. Instrument calibration, how well do our instruments work? This is an essential thing for even the simplest instrument, the thermometer, a balance, and for more complicated instruments. And I'll talk about that a little bit later on. And then documentation. Everything that we do needs to be documented. So when we calibrate the instruments, we produce records for calibration. When we do method validation, we produce standard operating procedure once we pick what the method is and what we have selected and the reason why. And then we stick with it, and so we have a sort of a paper trail to know that we're doing things right. So why do we run standards? We need to know what we're measuring, how true to the true value is what we're measuring. And so in some cases in our laboratories, but also in other areas of the plant, we do it directly. Like for a balance, we calibrate directly. We have standard weights that you see here, and we see if the balance is weighing that weight. In a lot of instruments, like the HPLCs that we use in the lab in an ethanol plant, we have to do an indirect calibration by constructing a calibration curve. So having something of known concentration and measuring the instrument response. And part of that is something that during the calibration you always have to run a blank because it tells you about the absence of contamination. And of course we have various types, reagent, instrument, or matrix blank, and this is important also for an ethanol plant to know what the baseline is so that you can detect any abnormalities or any problems that could come up. So here's a couple of examples that I wanted to show you. We have collected, over 1 year, we've collected the data for our HPLC, some of which you see pictured in this picture here. We do at least 2,000 or maybe more measurements than that in a whole year for fermentation-related studies. And so we could look at the whole fermentation panel of components from the DP4 to ethanol and look at what the relative standard deviation percentage is for all of those numbers. And as you can see, there's some numbers that are pretty good. 0.2% is pretty good, but there are some numbers that are pretty high. And those 3 culprits are always there, DP4 plus, lactic and acetic acid. The standard deviation is a little bit high, and there are reasons for that. And I wanted to talk about it before showing actual data. Well, this is actual data, but an actual round robin that we've done. If you look at a chromatogram from the HPLC, you can see that in part the reason why DP4 is always a little bit higher relative standard deviation value is because the shape of the peak has this little hump on the back, and that it depends where that eludes how that gets counted. And I don't want to go into the detail of that, but that's one of the things. The other reason is that the lactic and acetic acid they don't resolve perfectly with a refractive index detector, which is what it's used, and so the data is less reliable. However, going back to the slide, if you're having a stuck fermentation and the lactic acid is high, you will still notice it, and it won't really, it will be still predictable. But in terms of on a day-to-day basis, that's the uncertainty on the measurement. So occasionally we do tests between laboratories with NSERC data being the normalization data, because we take into account our uncertainty and the composition of the standards. And this shows a unknown that was sent to many participating ethanol plants, and it shows a box plot where all the concentrations I've shown you are normalized to NSERC, which would be the 1. And the box is the region where 25 to 75% of data points are. The red dots are the outliers, and the 10 to 90% of the data fall within the whiskers, so these error bars. So we see, as I was showing you, that the bigger box is where there's the most spread of data with the most outliers is DP4+. The lactic and acetic acid are also pretty bad, but ethanol is pretty tight around the average, with a couple of exceptions. And so the way we interpret these discrepancies are for a variety of reasons. One is there could be a sample handling problem between labs, and so we don't know if the sample was filtered or not filtered. These are just sugars made up, standards made up by us. Differences in peak integration, which is that slide that I showed previously, this one. The resolution of the chromatogram, meaning how well the peaks are isolated between each other, they're separated well or not. What units the labs were reporting, the type of calibration, if they use only 1 point versus multi-point. And when we talked briefly about what calibration is, I showed you that diagram with 5 dots and a line going through them. If you only calibrate a 1 point, you can't have a line. Well, you can have infinite number of lines going through them, but you don't know how true the calibration curve is. So that's one of the problems. And some of the calibration curves issues that we found out by the reporting labs. And the last thing is that the preparation of the calibration standard was unknown to us, and that probably the bought ones were also known to the participating labs. And so the standards that the labs were using to calibrate their instruments weren't very well characterized, and the certificate of analysis wasn't really reliable. So this is something that we haven't launched yet, but we have in mind to do. We're trying to see if there's any interest in having ethanol plants buy standards that we make. We would, provide 5 standards and 1 control sample, and recommend that the ethanol plant run the check standard every day and the full calibration once per week. We would provide a certain amount of email and phone technical assistance. We would provide a certificate of analysis, and shipments would be automated every 3 months. We'd send enough of the standards and control to run at under that schedule. So that's one of the things that we're thinking of. But this is not the only example I have. When we validate methods, we also validate how good the analysts are against each other. And this is an example of an assay that we were testing. And I'm just showing the numbers. And these are two analysts that were at NSERC. And I just wanted to show this example because over a period of days, these two analysts, they were performing the same assay and would get slightly different results. Now, the important thing to notice is that analyst A had an RSD that was about 4.5% day in and day out. So this is an example of systematic error or bias, which can be taken into account, and it's not a bad thing because it's consistent on every day. Analyst B, on the other hand, had an average RSD that varied wildly. So even though the analyst B had a pretty low RSD percentage on day 3, the performance wasn't consistent. So that's the kind of other stuff that we need to think about in the lab and try to capture who works better, who performs better with more systematic bias that can be taken into account and eliminated in the result versus people that are not consistent. And I don't mind telling you, Analyst B was actually one of the interns, so I'm not throwing anybody at NSERC under the bus. That was a learning experience for Analyst B, so in all, it worked okay. And it makes a nice slide to explain consistency of results. Let's give you a little bit of pilot plant data, and this is something I presented at FEW a few years ago in slightly different format. This is our pilot plant. We have batch fermentation and continuous front and back end, and we have mass measuring devices or flow meters on every unit operations, and we have the ability to insert other unit ops that we may not have for standard practice also with measuring devices. So we can get pretty tight numbers around mass balance, which is one of the things that I was talking about that is important to do quality control in. And as you can see, all the runs that we considered, we have pretty tight our average around slurry, liquefaction, fermentation, distillation. And centrifugation is a little bit less off, but there's a variety of reasons for that. And 6.9% difference is not that much if considering that these are different runs for different clients for different purposes. So one time we did a run of control fermenters, and this is just to show you how consistent we are from fermenter to fermenter in starch consumed, measuring ethanol. The measurement of ethanol is not done online. This is done in the lab. The mass of beer produced, we are pretty tightly contained. The mass of ethanol produced, and then the calculation based on the starch consumed of what the yield was. And it is expressed in percent or grams per gram of dry corn. So I just wanted to show that these are important things, and it pays to know if it's for the same purpose, how tightly one can control the mass going in and out. So those are the examples that I had that pertain to the theme of this afternoon, and a couple of take-home messages. If possible, compare yield results from independent methods. So if you have a couple of assays to compare the amount of starch, maybe you want to do that. Or if you have an inline measurement device and something in the lab, those are helpful too. Know what output to expect, or at least to know that given a certain amount of corn in, you would expect a certain amount out, and if not, start investigating why. Monitoring the fermentation is just as important as monitoring the quality of feedstock and co-products that go in and come out. And hopefully that's something that that comes across in this presentation, but also in general. We have ASTM standards for ethanol quality. We have standards for quality of grain and co-products. I think there should be a variety of standards for fermentation processes. And of course, running checks often in the plant and the lab is the only way to know what's going on. I want to thank you all for listening. And if you have any questions, please let me know. Thank you.
All right, thank you, Sabrina. We appreciate it. Well, now we have come to the end of our presenters, so we're going to ask a few questions here. One of the questions that came in while Scott was speaking while Shane was speaking, was what is, so I'll ask this question to Shane and then I'll open it up to anyone else that wants to tackle it if they do. Shane, what if my HPLC, just a second, sorry, my question disappeared here. What if my HPLC and GC machines are still using software for Windows XP, and because of this, the machines are not connected to our network due to security risks with XP?
Okay. That's exactly why we install our solution the way it is. By dropping our server next to that environment, we have a direct connection to the HPLC, leaving it on its own independent network. So in essence, we have multiple customers who have had Windows XP, never really upgraded the software, and are still running the original software.
Okay. Anyone else want to tackle that question? Scott or Paul?
We also drop this is Paul with Direct Automation. We also have a on-site server that manages and buffers information, so that way you can maintain that security at your site.
Okay, great. All right, I wanted to ask Scott a quick question. Talking about JUMP, you said there's kind of two categories, using it to fix problems or using it to experiment and improve performance. Is there a pretty fast payback on the software price for an ethanol plant?
Sure, it really will pay for itself in the first implementation, the first time you use it. It's very usual for our customers to go and whether it being fixing a current problem such as a quality issue, a downtime issue. Basically, JUMP can help speed basically the JUMP tool helps speed up not only the analysis and discovery of what's really going on, but help you lay out a solution and even present up that solution so the right decision gets made, and it just cuts down on time so you can get to your results faster. And so it can literally pay for itself in the first implementation, and that's just fixing a known problem. When you start to get to actually experimenting for a better product, for a better process, for a better design, then think about being able to hit all your goals right out of the gates and be able to get the right yield and the best quality at the lowest cost that operates within your system and still is robust to the variations in your process. And if you could hit that and you could be first to market and you can hit it at the price you need to hit it at, what would that mean for you? And so basically in the first use, you definitely can have JUMP all throughout your plant and everybody on the same page.
Okay, great. Paul, I just wanted to ask you, my understanding is that the majority of the ethanol industry is still handling their data with very simple with Excel documents. What are some of the things that a plant is in danger of losing when they handle their data that way?
Yeah, it's easy for Excel spreadsheets that are large to get corrupt or accidentally deleted and things like that. So the risk with using Excel and other paper forms and things is just the opportunity for it to be lost, and the ease of looking at it in the future is also lost. So that's where I think there's an issue with the Excel side of plants data collection, and we try to bring all that into one seamless package.
All right, thank you. One last question for Sabrina. Sabrina, you mentioned a program that could be coming soon to NSERC. That sounded pretty interesting. What would this depend on? What would need to happen for this to become a reality? And would this be something that, say, an ethanol plant would subscribe to for a payment situation?
Yeah, that would be that, and we'd be looking into commercially available standards, and we're not happy with the quality of many of them, and so we're looking at the prices, and we definitely can do something that is a reasonable amount considering what and a comparable amount. We haven't looked into all of this because we are just now starting to put together what all we would need to do. But we would like to start advertising it, and this was my first foray into letting people know that this could exist pretty soon, in case anybody that was listening works at a ethanol plant and is interested, could contact me, and that way we could see if there's an interest.
Okay, great. Well, thank you so much to all of our speakers and our attendees. Those are the questions that we have. Some of the questions have been sent to specific speakers if they were asked of a specific speaker. And now we're going to just wrap up with a little bit of information. First, we want to, again, thank the webinar sponsor, Direct Automation. The company is online at www.direct-automation.com. And there is also the opportunity for you to, anyone speaking, if you are interested in becoming a speaker at the 2015 International Fuel Ethanol Workshop. The deadline to submit your abstract or your presentation idea is February 6th. That's coming up fast. So FEW is the largest and the longest running ethanol conference in the world, and it is produced by Ethanol Producer Magazine. It happens this year, June 1 to 4 in Minneapolis. And to learn more or submit your presentation idea, visit www.fuelethanolworkshop.com. For those of you who are on this call, you can get a discount to FEW. All you have to do is enter the code FEW webinar when you register, and you'll save $250. And finally, here are some upcoming events you might want to know about. We have some other webinars that you might want to check out. The first on January 28th is a free webinar about project development. And the next is on February 11th. It's a biodiesel webinar on continuous flow enzymatic biodiesel processing. And then February 18th to 20 is the National Ethanol Conference put on by the RFA. And finally, as I mentioned before, our Fuel Ethanol Workshop coming up in June. Again, I'd like to thank all of our speakers and thank the attendees for listening in. There will be a recording of today's webinar posted online at Ethanol Producer Magazine, ethanolproducer.com later next week. If you have any questions, please feel free to contact us. Have a great day.